Good afternoon, and welcome to the first day of the space education grounding at your school. Space education, while seemingly a new concept to schools in Nigeria, has actually been a long overlooked, somewhat hidden part of the Nigerian education curriculum. The lack of focus on space education in Nigeria and most of Africa is the missing link in our quest for technological and economical development. What you are doing now is preparing your students to be the leaders of the generations that propels Nigeria to greatness. The first and most important thing you need to do is capture the imagination of your students. Space is one subject that will easily capture the imagination of both children and adults. Here are the resources we will be using to achieve this. The curriculum. This is a general curriculum that we encourage teachers to study themselves. Go through the outline. We expect to modify this to fit the class ranges from primary to secondary school. But for now, it is more than enough to empower your students. Space Clubs International will provide concise details, including videos for each module and lesson. Practicals. Space education must be taught always in a demonstrative manner with practicals and videos, something the students can see themselves. Avoid ever talking with no display. If you are talking about the moon, have multiple pictures and charts of the moon, including close-up ones. Public viewing homework. If you have a boarding house, have public viewing on your campus. If it's a day school, send students home with assignments that the teachers do themselves. Things they can view with their naked eyes. The star constellations, where Venus is in the sky at a certain time, for example, at 9 p.m. How many planets are visible on a particular night? Use of telescopes and binoculars. Binoculars are more affordable and good for viewing the moon and passing comets. They come in different types. Telescopes also come in different types. They are best for viewing planets, galaxies, and deep space. Binoculars range in price from $20 to $250. Telescopes from $50 to as much as $3,000. Your school will be provided with both binoculars and telescopes. Here's a suggested 3-term curriculum to teach students about space. Term 1. Exploration and the Solar System. Term duration 12 weeks. Weeks 1 to 2. Introduction to Space Exploration. 1. Topic: History of Space Exploration. 2. Objectives: Understand significance, milestones, pioneers. 3. Activities: Documentaries, timelines, space agency research. Weeks 3 to 4, the Solar System. 1. Topic: Planets and their characteristics. 2. Objectives: Identify planets, features, and relative sizes. 3. Activities: Planetary models and size comparisons. Weeks 5 to 6, the Sun and Stars. 1. Topic: Solar System center and the star life cycle. 2. Objectives: Understand the Sun's role, star types, and life cycles. 3. Activities: Solar System diagrams and star formation discussions. Weeks 7 to 8, Space Exploration Technologies. 1. Topic: Rockets, spacecraft, and satellites. 2. Objectives: Understand propulsion and spacecraft design. 3. Activities: Model rocket design and satellite applications. Weeks 9 to 10, Asteroids, comets, and meteors. 1. Topic: Small bodies in space. 2. Objectives: Identify differences and understand orbits. 3. Activities: Asteroid belt models and impact consequence discussions. Weeks 11 to 12, Review and assessment. 1. Quizzes. 2. Projects. 3. Presentations. Term 2, Space Phenomena and Exploration. The duration of this term is 12 weeks. Weeks 1 and 2 will cover black holes and dark matter. The topic is Mysteries of the Universe. The objectives are to understand black hole concepts and dark matter theories. Activities will include detection methods and simulations. Weeks 3 and 4 focus on space stations and habitats. The topic is Human space presence. Objectives include understanding space station purposes and habitat design. Activities will involve habitat design and space station operations. Weeks 5 and 6 delve into Mars exploration. The topic here is red planet geology and atmosphere. Objectives are to understand Martian features and exploration challenges. Activities will include image analysis and rover mission discussions. Weeks 7 and 8 cover space weather and radiation. The topic is solar wind and cosmic rays. Objectives are to understand space weather impacts and radiation protection. Activities will include examining solar flare effects and designing radiation shielding. Weeks 9 and 10 focus on astrobiology and extraterrestrial life. The topic is life beyond Earth. Objectives are to understand biosignatures and extraterrestrial hypotheses. Activities will involve habitability discussions and exploring alien scenarios. Finally, weeks 11 and 12 are dedicated to review and assessment. This will include quizzes, projects, and presentations. Term 3. Advanced Space Concepts and Future Exploration. The term duration is 12 weeks. Weeks 1 and 2 cover advanced space propulsion. The topic is future propulsion systems. The objectives are to understand emerging technologies. Activities include design proposals and discussions. Weeks 3 and 4 focus on space colonization. The topic is establishing human settlements. The objectives are to understand the challenges and opportunities. Activities include colony design and resource management. Weeks 5 and 6 delve into space law and ethics. The topic is governance and responsibility. The objectives are to understand regulations and implications. Activities include debates and case studies. Weeks 7 and 8 explore private spaceflight and commercialization. The topic is industry evolution. The objectives are to understand commercial space. Activities include business plans and market analysis. Weeks 9 and 10 discuss future space missions. The topic is upcoming explorations. The objectives are to understand mission objectives and challenges. Activities include mission design and proposal writing. Weeks 11 and 12 are reserved for review, assessment, and project presentations. Activities include quizzes, projects, and presentations. Assessment. Quizzes make up 40% of the grade. Projects and presentations account for 30%. Class participation and engagement also contribute 30%. Resources. These include websites, space documentaries, astronomy apps, space-themed books, and online forums and discussions. Let's get started.